Hey everyone, welcome to another two-dimensional projectile motion problem. This one we have a package being dropped. This is a rather long problem, so in this video number 45 we're going to be solving part A, and in video number 46 we'll be solving parts B and C, so stay tuned. So let's get started. A rescue plane wants to drop supplies to isolated mountain climbers on a rocky ridge 253 meters below. If the plane is traveling horizontally with a speed of 205 kilometers per hour, A, how far in advance of the recipients, in other words the horizontal distance, must the goods be dropped? B, suppose instead that the plane releases the supplies a horizontal distance of 452 meters in advance of the mountain climbers. What vertical velocity, up or down, should the supplies be given so that they arrive precisely at the climber's position? And C, with what speed do the supplies land in the latter case? Okay, now this problem actually comes along with a diagram. Okay, so here's our diagram. This is the one given in the problem. We've got our isolated climbers on a rocky ridge. We know that the plane's dropping the supplies to a ridge 253 meters below. Okay, the plane is traveling with a horizontal speed of 205 kilometers per hour. So let's actually add that in. Now here's the thing, because it's traveling with a horizontal speed, we can just label this as Vx equals 205 kilometers per hour. Okay, the package is dropped, so it's going to take the path of this red dotted line by the time it reaches the climbers. And because it's dropped, that keyword implies that the initial y speed is 0. This has already been given to you in the problem, so you don't have to come up with that, although it should still be clear to you that that is the case. And what we're looking for in part A is how far in advance of the recipients must the goods be dropped. So that is this x distance right here. So this is the idea. What we're looking for is a horizontal answer, right? Something with a horizontal component. And we know that x for the horizontal direction is equal to the speed in the horizontal direction times time. Now something else that should be clear to you is that there is no acceleration in the x direction. And that's been true for all the projectile motion problems we've done so far. Projectile motion means by definition that only gravity is acting on it. Okay, so Vx we have, it's 205 kilometers per hour. It's not in the right units, but we can always convert it after. That's not a problem. What we need to look for is t. And again, a lot of symmetry between this projectile motion problem and other ones. You usually find time from the other direction. In this case, we're going to find t from the y direction. So we're going to go ahead and start labeling what we know in the y direction, since there's a lot more going on. Okay, so here we go. In the y direction, we know quite a few different things. We know that the initial y speed, Vy naught, is 0 meters per second. We know acceleration in the y direction. Now, something I just missed to do is to actually label what direction is going to be positive, or what two directions. Okay, now for this problem, I'm going to allow up and to the right to be positive. So let me just do that right now. Okay, I realized this because I need to state the acceleration in the y direction, and because it's vertical and it's not 0, I need to establish a sign. Up is defined to be positive, therefore acceleration in the y will be negative 9.8 meters per second squared. What else do we know? We know the initial y height. We can set this height up here to be 0. That way, if it falls 253 meters, the final y height is going to be minus 253. So we'll say y naught is equal to 0 meters, and then y is equal to minus 253 meters. So it's all based on your relative point of view. Okay, now we need to find time. Now the equation that has all of these variables together is the following. So let's do that over here actually. Delta y is equal to v naught y t plus 1/2 acceleration in the y direction times squared. Okay. We know the v naught y is 0, so we can go ahead and cancel that out. Now, if this is 0, 0 times any number is 0. So this entire product here gets removed. I'm going to take my delta y, and you know it's actually equal to the final y minus the initial y minus y naught. Now, y naught is 0 as well. So there you go. That disappears as well. So we're left with y equals to 1/2 acceleration in the y, t squared. Okay, so we've got this expression. We need to solve for t. So what I'm going to do is multiply both sides by 2 to get rid of the half, divide both sides by acceleration in the y to get rid of that, and then we'll take the square root of the entire expression. So you're going to end up with 2, that should be a y. Then you're going to end up with 2y over a sub y would be equal to t squared, but if we take the square root of both sides, you end up with t equals root 2y over ay. Okay, so let's start plugging in our numbers. T is equal to the square root 2y. Remember, y is minus 253 based on this. So minus 253 meters divided by acceleration in the y. Also, it's going down, so negative 9.8 meters per second squared. And when you solve this expression, you're going to notice, first of all, that the minuses are going to cancel out, okay, leaving you with a positive root. Otherwise, you cannot take the square root. So you're going to get t equals 7.19 seconds. And this number, we're going to take and we're going to plug into the x direction. Okay, so let's go ahead and do that. Okay, so remember, in the x direction, we started off with straightforward expression. The distance covered is speed times time. Time we have now, speed is given as 205 kilometers per hour. Now we have to convert that. Okay, so I'm going to do that on the side here. Okay, so Vx is equal to 205 kilometers per hour. We need to convert this to meters per second. Now, if you watched my very early videos, I show you a few times how to convert it. Okay, I'm going to go ahead and use the same method now. Every time you want to convert a unit, like here we have to convert 2 units, kilometers and hours. So I have to multiply by 1 2 times. Now again, the reason we multiply by 1 is because if you multiply by any other number, it's going to change the expression. And if you're wondering why would I multiply by 1, I'm going to get the same answer. Well, the answer to that is I need to choose an appropriate 1 so I can change the units. Okay, so you'll see what I'm talking about in a moment. Okay, so this is going to be equal to 205 kilometers per hour. And you know that with the number written like this, it's technically in the numerator. It's technically 205 over 1 hour. Okay, the first one I'm going to choose is going to get rid of my kilometer unit. Now, because I want to get rid of kilometers, I'm going to write it in the denominator. The unit that I'm trying to get at is the SI unit for distance, which is meters. So then you ask yourself, what ratio of meters to kilometers gives you 1? And well, it turns out that 1 kilometer is 1,000 meters. Okay, so there's that. That takes care of our kilometers. And the next one you multiply needs to take care of your time measurement. We're trying to get rid of hours, so you put hour on top. The unit we're trying to get out is seconds. You put that on the bottom. How many seconds are in an hour? Well, there are 3,600. Now, by doing that, let's take a look at what we've got. The kilometers cancels out with the kilometers. The hours cancels out with the hours. And the units you're left with are meters per second. So all you need to do is 205 times 1,000, and that's going to be meters. And then denominator, you're going to do 1 times 3,600. Okay. When you solve all of that out, you are going to end up with Vx equals 56.94 meters per second. And that's what we're going to use here. So let's go ahead and plug that in. So x is equal to 56.94 meters per second times time, which we determined earlier to be 7.19 meters per seconds, pardon me. When you multiply the two of those together, you're going to get the x to be 409 meters. And just to be sure, our two initial values given in the problem, 253 meters and 205 kilometers per hour, are 3 sig figs. This is also 3 sig figs. So that is how far in advance the supplies need to be dropped in order to reach the climbers on the rocky ridge. So there is your answer to part A, 409 meters. To catch parts B and C, please stay tuned for video number 46, which will be uploaded shortly. Okay. Thank you guys so much for watching. As always, if you like part A, if you like this video, be sure to click that like button and subscribe to this channel so that you never miss a video from me. Thank you guys, and I will catch you in the next video with parts B and C.